Hi there. In this video I'm going to be showing you how to use this button here on your calculator. It's the fraction button in order to work out the effective resistance of resistors in parallel. Now the easiest way to do this is to show you an example question. This is the first one. I'm going to work out 3 in fact in this video. So the question says calculate the resistance between points X and Y in the following arrangement of resistors. Now first thing to remember is that the equation you use is this one here. So 1 over RT is 1 over R1 plus 1 over R2. Now if I had 4 resistors in parallel, I would also continue plus 1 over R3 plus 1 over R4. In fact, if you look at the relationship sheet, it's actually written like so: 1 over RT is equal to 1 over R1 plus 1 over R2 plus ... for as many resistors as you have. Second thing to remember, of course, is that the effective resistance is always smaller than the smallest individual resistance. So the smallest resistance here is 10 ohms, so the effective resistance is going to be less than 10. Next thing I'm going to do is I'm going to write in this, which is my substitution. So that would be 1 over 10 plus 1 over 20 is equal to, and this is the point that I use that fraction button in the calculator. So press it now, and I type 1, then I press down, 10, then I press right, and plus. Press a fraction button again, 1, down, 20 is equal to, so that gives me 3 over 20. Now this is not the effective resistance yet. This is just the value of 1 over RT. So the important thing is if 1 over RT is 3 divided by 20, to find RT I just want to flip this upside down, and that'll give me RT. So that means I need to flip this side upside down as well. So therefore, RT will be equal to, as I said, this flipped upside down is 20 divided by 3. So let's work out what 20 divided by 3 is in our calculator. 20 divided by 3 is, of course, 20 divided by 3. That's an awful lot of use. So what I'll need to do next is to press that SD button. And it tells me 6.6, but there's a dot above the 6, which means that that 6 is recurring. It's going on and on and on forever. What I should do again is to press that SD button to show me the long form answer. And that just tells me it is 6.66666. So I should actually write my answer to, as you can see in this question itself, this resistance is written to 2 significant figures, as is this one. So I should really be writing my final answer to 2 significant figures. So of course 6.66666 recurring would be rounded to 6.7 ohms. Now remember that thing as well, if you have recurring decimals in physics, that's not allowed. So you should be writing the final answer to the same number of figures as the number in the question with the least number of figures. There will be another video about this coming out soon. Let's have a look first of all at the next example. So the next example, just move that up there, is again we're going to be using this equation. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 in this case. We've now got 3 resistors. But the question says calculate the resistance between points X and Y in the following arrangement of resistors. I'm getting deja vu, sounds a lot like the last question. The only difference is, of course, that the resistances are in kilo ohms. So what I should do is, when I do this substitution, then of course I should be incorporating that into the substitution. So that would be 1 divided by the first resistance up at the top is 10 kilo ohms. So that's 10 times 10 to the power of 3 plus the second one is 15. So 1 over 15 times 10 to the power of 3. And the third one is 20 kilo ohms. There we go. Now what's that going to give us? Let's find out. Okay, let's enter that into the calculator. So we'll press our fraction button, 1, down, 10 to the power of 3, press right, then plus, fraction button again, 1, down, 15 times 10 to the power of 3, press right again, plus fraction button, 1, down, 20 times 10 to the power of 3. There we go. And that gives us this 13 over 60,000. So 13 divided by 60,000. So again, this is 1 over RT is 13 over 60,000. So that means that RT itself, I want to flip this number upside down, is 60,000 divided by 13. And that gives me, let's find out, 60,000 divided by 13. I know what this is going to tell me. It's going to tell me that this is 60,000 over 13. Wonderful. So we press that SD button again. Couple of recurring decimals, so press SD button again. Now, how many figures should we be writing this answer to? Well, again, the values written in the question, they're all to two significant figures. So really, I should be writing this to two significant figures, and that number 4,615.384615 should be written as 4,600 ohms. Now, it is possible, and you will be allowed to write two figures too many, so you'd be allowed anything up to 4615 and one significant figure too few. But it's always best to know how many it should be written to. Now, our last question looks like so. So in this question, I actually have two parallel branches. On the left hand side, I have 120 ohm and a 60 ohm, on the right hand side, an 80 and a 20. Again, it's just asking us to calculate the resistance between points X and Y in the following arrangement of resistors. So what you would actually do in this question is you would work out the effective resistance of the two resistors on the left, and then you would work at the effective resistance of the two resistors on the right, and then you would add those two values, those two resistances. So what I'm going to write here is I will work out the, let's see, resistance of the left hand side branch to start with. And again, I'm going to use 1 over RT is 1 over R1 plus 1 over R2. Of course, that's 1 over 120 plus 1 over 60. Hopefully I should just have enough space to work out that, or to write in that answer. So let's see, press, whoops, sorry, I'm doing that wrongly. So press the fraction button to start with, remember. 1 and then down, 120, and then click right, plus fraction button again, 1, then down, 60, and that gives us 1 over 40. Now, the important thing again is that, therefore, RT is equal to, that we flip this right hand side upside down. So obviously if 1 over RT is 1 over 40, then RT itself is just 40 over 1. So we could write that. We don't have to write this part because of course 40 over 1 is just 40 ohms. Now what I'll do next is I'll work out the resistance of the right hand side branch. And again, I'm writing this equation, 1 over RT is 1 over R1 plus 1 over R2. In this case, that's 1 over 80 plus 1 over 20. And we'll work at that. And what does it give us? Start with the fraction button again. 1 over 80 plus, whoops, made a mistake, click right, plus fraction button again, 1 and down, 20. That gives us this, 1 over 16. So of course, if again 1 over RT is 1 over 16, then RT is equal to 16 over 1, which is 16 ohms. And that means, of course, that if we have the branch on the left with a resistance of 40 ohms and the branch on the right with a resistance of 16, of course, both of these two parallel branches, they're in series with each other. So we can just say that the total resistance is equal to, and of course with resistors which are in series, and here we have two branches which are in series, we just add the two resistances together. So that would be 40 plus 16 is of course equal to, I'll not use the calculator for this, 56 ohms. So there we have it. As I said, this is a method which wasn't given in the previous video that I made. If you want to watch that one, of course, that'll show you two different methods to use when you're adding resistors in parallel. But I would say that actually this is the simpler version. Hopefully that's helped. We'll see you next time.